My name is Farah, Shahira, binti Romzi, and I will present for the part security module. For security module, we divide into two systems, which are door lock system using 4x4 keypad and gas leakage detection system using anti-theft sensor. For the door lock system using 4x4 keypad, our system is, first of all, we will enter the password using the 4x4 keypad, and then the password entered will be displayed on the LCD connected through microcontroller at Mega 32. And if the password is correct, microcontroller will send information to the mini support motor to take action, and then the door will be open. For this system, our main components are 4x4 keypad, 16x2 LCD display, and the servo motor.
This is the flowchart of the door lock system using keypad. First of all, the user will enter 4-digit password by using the keypad, and then the system will compare the key in value with the stored value. In the end, the result will be shown by the LCD display. If the password is correct, the LCD will show access, while if the password is incorrect, the LCD will show denied. This is the schematic diagram where we can see that the LCD display and the keypad is interfacing with the Mega 32. For the software part, this is the coding that we will be used for the system, and this coding are based on the flowchart in the slides that shown before.
The second system for our security module is gas leakage detection system using anti-theft sensor. This system is used to prevent accidents due to gas leakage and to get report leak alert message if the gas is leaked. The main components for this system are anti-theft gas sensor, microcontroller, LCD, and GSM module.
And then this is the schematic diagram where we obtain and refer from the internet.
Okay, for this time, we proceed to the communication module. Okay, for the communication module, we have two components. The first one is GSM SIM900A module, and the second is Bluetooth module HC05. Next. Okay, for the first time, we proceed with the GSM SIM900A module. This is the flowchart of the GSM SIM900A. The first one, when we put the input from the various variables, it will detect by the various sensors, which is the MQ5, which is detect the gas, DHT level, which is detect the humidity and temperature, LDR detect the presence of light, and water level detect the level of the water, precisely flood level. And then it will send the data into the Mega 32. The Mega 32 acts as microcontroller that sends the output action that can be taken to the GSM SIM900A, which sends SMS impulse or notification to the smartphone or gadgets. This is the schematic for the GSM SIM900A module that interfacing with the Mega. As we can see, this is the GSM module, this is Mega, and this is the LCD 16x2 display. And then this is the coding for the GSM SIM900A that connect with the Mega 32. And then we will proceed to the Bluetooth module HC05. Okay. For the Bluetooth, we precisely use it to detect the vibration or the earthquake. We use the accelerometer sensor to detect the earthquake or vibration, and then the data will send to the Mega 32, and then it will take an action and send to the Bluetooth module HC05, which is it also can send the SMS notification based on the application software that we put in the smartphone. And then this is the schematic of the connection between Mega 32 and the Bluetooth module HC05. And this is also the LCD that will display the notification. in the Islamic feature module. In Islamic feature module, we have three components. The first one is musalla, which is the prayer room or area, and then next is mashrabiyah, and the third one is real time clock, which is indicate that the time is very important in Islam. Okay. This is the mashrabiyah design. As we can see, it has holes for the air ventilation, which is used to cool the area or give the pleasure to the people in the area. And then we proceed with the real-time clock. This is the image of the real-time clock. For the schematic, as we can see, there is connection between Atmega 32 with the RTC module itself and also with the LCD 16x2. The function of the LCD 16x2 is to display the clock itself. And then we proceed with the coding. In the coding, we have two parts. The first part is for the setting clock and calendar to RTC. For the second part, it is used to reading time and date value from RTC.
For the water level indicator, the water level indicator will attach into the water tank which is placed below the room area, and it will measure the consumption of water usage by the user before it is discharged to the piping system. And for this, we will use different color of LED to indicate the water level. When the water level is critical, the red LED will turn on and the buzzer will produce sound to warn the user about the water usage. And these are the list of the components that will be used for the water level indicator: the transistor, resistor, LED, and buzzer. This is the schematic of the water level indicator. We will use 4 transistors, 3 resistors, and 3 different color of LED, 1 buzzer. So the transistor will act like a switch or sensor to detect the water level, and the LED will produce signal that transmit from the wire connected to the transistor, and the buzzer will produce sound when the water reach a critical part and act as an alarm. For the solar energy system, the system will generate a power of electricity from the sun by using the polycrystalline solar cell. The polycrystalline solar cell will indicate the sunlight and form it into the signal in terms of electric flow, which will supply to the diode rectifier, passing through the Li power boost converter by converting the signal. So the list of the components that will be used are diode rectifier, Li power boost converter, 5.593 inch 1.3 watt polycrystalline solar cell. Thank you.
For the climatic monitoring module, the main component that we use in our system configuration is DHT11 sensor, servo motor, LDR sensor, and we have also DC motor and Atmega 32 that acts like a brain in our system, and also LED. This is the schematic design about our system, which is climatic monitoring module. We can see that this is the mechanism behavior of climatic monitoring response, which is when we detect a wet condition detected by the DHT11 sensor, it will sense the signal through the Atmega, and the Atmega will process the signal and transmit the signal to the servo motor. Then the servo motor will react the roof to move downward. In our house, when we have also a high temperature, the HT11 will detect the high temperature and will transmit the signal through the Atmega, and the Atmega will send the signal to the DC motor and fan will be turned on. LDR also will detect the low light and transmit the signal to the Atmega, and LED will turn on. This is the basically of the DHT11 that's connected to the Atmega 32, and we have include the LCD also, which may be used in our project. There is the coding, how it's work regarding to the DHT11s, and we will use it and still testing whether there is work or not. May I have a look. For this schematic, it involves about one component, which is LDR, that we can know the LDR will detect the system regarding to our light in our house. Next, this is the coding. Maybe will be works in our project. That's all. Thank you.